Okay, this is part 3 of our introduction to relativity. And this time we're going to talk about simultaneity, that is, whether two events are simultaneous or not. We'll learn some surprising things. It turns out that Einstein was not an experimentalist. He did a lot of his experiments really as thought experiments. He'd ask himself, what would happen if I did something? And that gave him all the evidence he needed in order to come up with some interesting theoretical results. So we're going to take a look at a thought experiment right now. We're going to imagine for a moment that, that we've got a captain who's flying a spaceship. And so let me draw our spaceship here. We actually have a small fleet of spaceships. There's one. Two. 3 spaceships. And again, our captain here will be in the middle spaceship. So here he is. They're small spaceships, and we'll have 2 crew members, one in each of these other ones. They get to sit down. There's one crew member and another crew member. Now this captain is a very old school militaristic guy, very regimented. He likes everything to be done kind of in lockstep, in unison, even when it comes to simple things like eating lunch. Yeah, he's kind of a peculiar guy. So he's trying to think, how can I be sure that my crew members in each of these other 2 ships will really eat lunch at exactly the same time? And he comes up with a plan. He decides, I'm going to put an antenna on top of my ship here, and then I will send out a signal to those other 2 ships. Beep, beep, beep. Beep, beep, beep. And in that signal, I will encode a message, and the message will be, eat lunch. And the captain knows, since the 3 ships are all equidistant from each other, and that this signal, he'll use a radio wave. Remember, radio waves are just another example of light, and so it's a light signal. He knows that that light signal will go equally fast in both directions. It'll go equal distances, and consequently he knows that that signal will reach his 2 ships simultaneously, exactly the same time. And his obedient crew members will then eat their sandwiches. Here, we'll give them each a sandwich. This guy's got his sandwich, and a sandwich over here. He knows that his 2 crew members then will eat their sandwiches at exactly the same time, and this makes the captain very happy. Okay, so this is what everything looks like in the captain's frame of reference. But now what we're going to imagine is that that captain is so pleased with his device, his scheme here, that he wants to show off in front of the admiral. And so we'll make another ship. This is the admiral's ship. Here, we'll label this one Admiral. This is our captain up here. Okay, and so he's going to show off in front of the admiral when his ships are all flying by. So you can imagine the whole fleet's on parade here. Our whole fleet of 3 ships is on parade. They're flying past the admiral at very high speeds. And right as they go past the admiral, the captain's going to send out his signal. Beep, 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 eat lunch. And then both his crew members will eat lunch at exactly the same time. And he's hoping that the admiral will be just as pleased by this as the captain is. Well, now we're going to look at what happens from the admiral's frame of reference. And so that's what I want you to take a moment and figure out. I'd like you to determine who will get that signal first in the admiral's frame of reference. So again, here's the question to consider. Okay, that's our question. Which ship will get the signal in the admiral's frame of reference? And what I'd like you to do is just take a moment, pause the video, and give this some thought. Okay? And don't tune back in until you've got your answer. It's not a hard question, but it's really important that you think about this and figure it out. Okay, so you got your answer? Here we go. I'm going to go ahead and work out. Hopefully you got something similar. And if not, maybe my line of reasoning here will still make sense to you. I don't think it's a confusing thing. So what's going to happen in the admiral's frame of reference? Well, in the admiral's frame, the captain sends out a signal, and while that signal is traveling to each ship here, the ships are going to be moving. So let me draw where the ships will be a moment later. So for example, this ship will have gone some distance. Let's see, I'm on a pencil. Let me go back to pencil here. Okay. So there's that ship after the signal has reached it. Likewise, the captain's ship will have moved some distance, and the other crew member's ship will have moved. Okay, so all three ships will have moved while that signal is traveling. Well, let's make that signal drawn all the way back to them. So, so 4 more of these. We'll do 4 more this way. 1, 2. Okay, and so what we see is the signal has now reached the back ship, and yet it hasn't reached that front ship where the front ship now is. Okay, so this is the important point. In the admiral's frame of reference, while the signal is traveling, the 3 ships are moving, and so the back ship's kind of running into the signal. The front ship over here is kind of running away from the signal, and consequently, in the admiral's reference frame, the back ship will get the signal first. So that's the answer to our question over here. So okay, so that's what happens in the admiral's frame of reference. That's it. Now you may be wondering, is this okay? I mean, think about what's going on in the captain's frame. In the captain's frame, we said that, are those ships moving? In the captain's reference frame, the front ship is just sitting there out in front of him, the back ship sitting there behind him. They're not moving at all. And so in the captain's frame, that light signal goes equally far to the 2 ships. It goes equally fast, and so they both get that signal at the same time. So in the admiral's frame, the back ship gets the signal first. In the captain's frame, they both get that signal simultaneously. You have to think about that for a moment. Is that really okay? Can you have it both ways? You might be asking yourself, well, what really happens? And the answer is that in the reference frame of the captain, the 2 ships really get the signal at the same time. In the admiral's reference frame, the back ship really gets the signal first. It really is both ways, different in each of those 2 reference frames, which hopefully you find a little bit disturbing. Because I'm guessing before today you probably thought that events were either simultaneous or not, and that doesn't depend on your reference frame. And what we're seeing here is it actually does depend upon your frame of reference. Now, there's some other things which you know depend on your frame of reference. For example, you know that if you measure someone's velocity, I could ask you, what's your velocity right now? And if you're sitting still, you'd probably say, well, my velocity is 0. But the follow-up question ought to be, relative to what? I mean, relative to your chair, relative to the room you're standing in there or sitting in, your velocity is 0. But compared to the center of the Earth, well, the Earth's rotating, and so you're probably moving about 1,000 miles an hour to the east. You'd be even moving faster compared to the sun, probably more like 18,000 miles an hour compared to the sun. So your velocity, you already knew, depends on your reference frame. You have to say, well, here's my velocity relative to this thing. And what I'm saying now is whether events are simultaneous or not also depends on your reference frame. There are some more subtle examples of things depending upon your reference frame. For example, you can imagine for a minute that we've got a truck. Here, let's go ahead and draw a truck. We'll go back to our pencil. We'll get some wheels. And make ourselves a road. Right? And imagine maybe that you're standing on top of that truck. You know, I don't advise this behavior. This is kind of the James Bond maneuver here. You're standing on top of the truck, and perhaps you're holding a ball. Okay? And first we'll say, what's going to happen? What's going to be the path of that ball if the truck is driving and you let go of the ball? So a moment later, the truck will be over here. And we'll give it wheels, and you're still standing on top. And hopefully you remember back from early in the year, if you take that ball and you just let go of it there, then its path compared to the ground, well, it's going to have the velocity of the truck, and so it should move like that. It should be a curved path, and I didn't draw that too well, but you get the idea. That should be a parabola. It had the velocity of the truck going sideways, but it was accelerating downwards, so you get a curved path, a parabola, right? That's the path of it relative to the road. So you can imagine if you had a bystander, somebody standing over here, that's the path they would see. They would say, oh yeah, that ball, it went in a parabola compared to the road. But what about compared to relative to the person standing on the truck? Well, relative to the person on the truck, the ball started out right in their hand and it wound up right below their hand. So compared to the person on the truck, that ball just fell straight down. It started up here and it fell straight down. Right? So, in fact, the path at which something falls actually depends on reference frame as well. In one reference frame, compared to the road, that path is really a parabola, whereas compared to the truck, that path is really a straight line. Both are true. And so we see there are lots of things which depend on a reference frame. And it turns out that this idea of simultaneity, whether events are simultaneous or not, is just one more thing which depends on your reference frame. So if this is true, you might be wondering, why haven't I noticed this before? It should be something which would come up at various times. For example, you can imagine that you're driving a car and you look in your rearview mirror and you suddenly see the lights on and a patrol car behind you and you're thinking, uh-oh, what have I done? You pull over and the officer walks up to your window and says, you just entered that intersection right after that light turned red. And you're like, no, officer. In my reference frame, what really happened is my car entered the intersection after or before it turned red. And what normally happens then? Does the officer say, oh yeah, you're right in your reference frame, you can go ahead? Is that the way it goes? No. You haven't noticed before, probably, that things are truly simultaneous in one reference frame and truly not simultaneous in another. And the reason for that is you have to go back and consider, how fast was this spaceship moving? So let's answer that question here. Let's look at how far that spaceship moved. So the spaceship, while that light signal was traveling, that spaceship moved about that far. Okay, we're going from the blue one to the green one. And then you can compare that to how far did the light signal move. So the light signal moved about this far. And if you look at those two distances, you see that the spaceship here moved, what is that? It's about a third. That spaceship moved about a third as far as the light signal did. That means that spaceship is going a third of the speed of light, which is really fast. Okay? Consider how fast your car would be moving. Your car might be going 30 meters per second instead of 300 million meters per second. So that's, a 10 millionth of the speed of light. So how big, what would the scenario look like if the spaceships were actually moving only 30 meters per second? How far would they have moved? Well, barely at all while that light signal was traveling to them. And consequently, the back ship will just barely move during that time, and it'll get that signal just a tiny bit. We're talking billionths of a second before the front ship would get that signal. And you're not going to notice billionths of a second, nor would a police officer or anyone else. So you've never noticed this effect of relativity of simultaneity. But it's important that you know that it's happening at any speed. Even at low speeds, it happens. Events are not simultaneous for everyone. It depends on your reference frame. It just becomes much more noticeable when things are moving a good fraction of the speed of light. Okay. So I think that's all that we've got for this particular installment. Next time, we're going to be considering what these two postulates of relativity do when we start measuring time intervals. So we'll look at time and relativity.